Oh, it went all the way. Air bubbles? Coming
Yep.
up. Air bubbles.
Hold this. Hey, let's go.
Well, the sink and float test was
It's
successful.
sunk and it floated.
Let me see. Put the camera on.
Woohoo!
So in the case this is a legacy project, I wanted to give an overview of the glider's pressure vessel so that future senior design students could use this as a reference to pick up where we left off. So this is the entire pressure vessel assembled, and starting off there are three main sealing points: the head end cap, back end cap, and the pressure tube's NPT gland seal. And those are the three main sealing points. And the pressure sensor, which has a tube on it that extrudes out the back and is sealed right here, is mounted on the inside carriage. So even if you loosen up this hose clamp and pull it up, if this NPT gland is still tight, you'll end up trying to rip the pressure sensor out of it. So first off, we're going to loosen the NPT gland cap, take that off, and from there loosen the back end cap hose clamp. Takes a little bit of force to remove that. There we go. And then we also have a custom made O-ring for the back end cap. And then also, last but not least, the head cap and seal. Loosen that hose clamp. And then just kind of wiggle it out of there. And here we have the pressure vessel's carriage and its tube, the tube body of the pressure vessel right here. So with the pressure vessel tube body removed, I wanted to go over some of the components that are on the carriage assembly, which is all the internals of the pressure vessel, starting with the head end cap, and then we have the head block, these syringe cylinders, these syringe plungers, there's 4 of each, the plunger plate, the motor plate, perforated control board for modularity to load up any sort of different circuitry you may need, the back end ring, and all of these are bolted into place on the 1/4 inch threaded rods, which are the carriage rails, with nylon locking nuts. And these carriage rails go through the head block and are bolted onto the face as well as the back side to hold everything in place. And there is sealant along the inside of the head end cap. There's a large hole in the head end cap that the head block sits in, and it's sealed into place. Sealant is laid, and then the head block was put into place for watertight sealing, as well as the carriage rail holes that go through the head block. There is sealant in those as well as filling the hole, the pilot hole that the bolts on the face of the head block are in. The current circuit that our glider uses a Arduino Uno as its microcontroller, 30 psi pressure transducer, infrared receiver module, which we'll get to in just a bit, our back end limit switch, front end limit switch, and our breadboard, which our DRV8825 stepper motor driver is mounted to, and also a 47 microfarad capacitor, which is in parallel with the power going to our NEMA 23 stepper motor. Connected to the shaft of the stepper motor is the stepper motor coupler, and in the stepper motor coupler is also bolted in is our 8mm lead screw. On the lead screw is the screw nut, and bolted to the plunger plate are the not only the plungers but the screw nut as well, so that as the motor spins, the screw nut follows back and forth along with it to either push out or pull in water. And it's all powered from the battery bay underneath, which we'll take a look at now. Well, before we turn it on, I'll show you how to insert the battery. So make sure this is kind of dangling off to the side. Lower this onto the rails above those screws right there. Slide this in, and then there's two nuts on each side of these rails that these just sort of lock into right there. Plug in the DC jack, and then turn the power switch on. One of the benefits of having a transparent pressure vessel tube body is that we can not only see what's going on inside of the pressure vessel, but we can also give it commands using the infrared receiver module and a remote. And while it can't penetrate water, the signal can't penetrate water, it can penetrate the Blended Wings fiberglass body, so long as the pressure vessel is in its initial starting position at the surface. So now that the glider has power and is turned on, I wanted to go over some of the current functions that are programmed into the microcontroller right now. These first four functions are going to be test functions to figure out things like how much additional weight needs to be added, the rate of ascension or descending, or what sort of starting position the plungers need to be at for whatever sort of setup that the pressure vessel is under on the outside of it. So the first is going to be the fast forward button, which is going to take us to our front end limit switch for maximum buoyancy and to achieve floating. The next is going to be the rewind button, which is going to do the opposite. It's going to take us all the way to our back end limit switch for the minimum amount of buoyancy to achieve sinking. So next we have our up and down buttons, which is going to send 200 pulses to the stepper motor, resulting in 1 revolution or 8 millimeters of displacement. So move it up, 8 millimeters, 16 millimeters, 24 millimeters, back to 16 millimeters, 24, and you get the idea. And those are the test functions. The main functions consist of the positioning function and the cycling function. And the positioning function is going to take the plunger plate back to the back end limit switch and then forward to the plunger's starting position for cycling. And that starting position is pre-programmed into the function. So number 1 is positioning. So now our plungers are about halfway through their maximum displacement and they're ready to start cycling. They're just floating but ready to begin sinking as soon as they start pulling in water. So the second button is going to be our cycle. It's set for 3 cycles currently, but of course that can be adjusted. So number 2, cycle. So everything from the torque to the speed to the delays in between, the displacement, its starting position, those are all variables that can be controlled in the code. So that's our initial cycling program. So with the pressure vessel fully assembled and turned on, we'll do the cycle now. So it's pulling in water, and as it's doing that, it's pressurizing the inside. And you can see that as the back end cap sort of lifts up. And then as it expels water through the cylinders, it relieves that pressure as well. But never going into a vacuum state beyond its starting position. That's why the torque required is so important, to be able to push through that back pressure. And the more torque is going to cause a lot more vibrations, which is why we use those nylon locking nuts.
Come on, baby.
You know you want it.
You know you want to sing. Come on.
Little girl. It went down a bit.
So I would almost call this an improvement over the last one.
I might, yeah.
Wait, can you try pressing it again?
Well, yeah, I think it's running. It's just
It came back up, right?